I'm Lisa Oliver. I'm a member of SESOC's Sustainable Design Task Force and also a structural engineer with homes in Christchurch. It's fantastic to have you all here to join us today for the SESOC webinar to launch our top tips for low carbon design. So to start the session, I'm going to provide you with a little bit of background on the top tips and share a few results from a survey that we conducted as part of this research. And then we will hear from 4 structural engineers on how they have actually used these top tips in some of their projects. So we have with us today Jared Keane, Technical Director at Beca, Robert Lane, Associate at Lewis Bradford, Nick Carman, Technical Director at Mott Macdonald, and Phoebe Moses, Carbon Navigator at Beca. All going well, we'll still have plenty of time at the end for questions. So why are we here today? Well, we all know we're in a climate emergency, and as a society, we need to be moving towards a low carbon economy. So it's increasingly important, no matter what profession you're in, to being responsive and knowledgeable about reducing carbon. Now, as structural engineers, we actually have a huge opportunity to contribute to climate action through our designs. Globally, building and construction contribute to around 40% of global greenhouse gas emissions. And roughly half of these are embodied, and roughly half of those are from the structure. So SESOC and the Sustainable Design Task Force are really keen to support our industry in lowering our embodied carbon with actionable steps to lower embodied carbon design. So, what we've heard from structural engineers in New Zealand is that one of the biggest barriers to low carbon design is a lack of guidance and information, specifically New Zealand focused guidance and that targeted at structural design. So SESOC are really proud to be able to launch our by practitioners, for practitioners, resources on lower carbon design. So we've created 2 different resources, a resource map, which compiles a whole lot of what we think are the best resources out there, both locally and globally, to assist you with your structural design. And then we've distilled these down to our top 20 tips, which is what we're here to talk about tonight. And all of this was supported by SESOC and with some funding from brands. So to kick off the project, we looked to measure the engagement in sustainability in New Zealand, in structural design in New Zealand. We did this with a survey, some focus group discussions, and pooling the knowledge from the research team, which was made up of members of the Sustainable Design Task Force. So I'm going to share with you now a few highlights from the survey, but I'm going to go through them really fast. And there are some small numbers on the slides, which you probably won't be able to read. So if you have any specific questions, please reach out afterwards or at the end. And thank you all. I'm assuming that a lot of you will have participated in the survey. So we started asking a few questions around the demographics of those who were participating. We had a mix. We had people from all over the country, but for some reason, those in Canterbury were the star performers with the highest turnout of participants. We had people from a good range of people from different size organisations. What this slide is showing is that the majority of our respondents work on small to medium projects from the private sector. And the pie graph what that's showing is that we had a really good range of career level. So almost 40% mid-career, 40% senior leadership, and the remainder early career and students. After we had found out who was responding to our emails, we asked, to the survey, we asked a series of questions about people's perception of knowledge and drivers and barriers around sustainability at 3 levels: their personal level, organisational level, and for their clients. So this slide is showing some of the results of how people perceive their own knowledge of sustainability, with the different colours of bar chart indicating different knowledge areas. So what was interesting to see is that at least 75% of our respondents indicated that they had some knowledge. On the chart, you get more knowledge as you go to the right-hand side. So the big spike in the middle are people who said they had some knowledge, but they're not at the point yet further to the right of working independently. Less than 5%, fortunately, said that this area of knowledge was not relevant to them, and 20% said they had little knowledge. It was structural engineers in their mid-career that had this highest self-rated knowledge. So then we moved on to asking people about the importance of sustainability to their organisations. So around 30% said that it was a #1 factor considered by their organisations alongside efficiency and cost. Another 30% said it was a second tier criteria. 20% said it was considered by their organisations, but only if it was required by an external party. And the 13% at the top said it wasn't considered at all. Then we asked about how mature organisations were with regard to sustainability, and you can see the bulk of people sort of said 7 out of 10 they thought their organisations were reasonably mature, and the main action areas, by far, measuring embodied carbon came out on top. When we dig into what organisations were doing a little bit deeper, we found that a lot of them were putting sustainability into their strategy, creating new roles, and committing to carbon reductions. So a lot of talking, but perhaps not a lot of doing just yet, because the things that weren't selected were things such as including sustainability and doing embodied carbon calculations in standard scopes of works, mandating sustainability reviews, benchmarking, or setting public commitments. When we got up to the questions around the importance of sustainability to our clients, what we found interesting was that only 10% of people said it was a #1 factor for their clients alongside efficiency and cost. Around the same number as with the organisations put it as a second tier criteria, and a similar number also of 20% said it would be considered if it was specifically required by an external party, which means the main difference between our organisations, the response for people's organisations versus their clients, is this growth in the sustainability not considered at all, which for our clients went up to 34%. When asked about what people thought the main drivers for our clients are, Number 1 came in at meeting publicly declared targets. Number 2, minimising use of materials. And number 3, the desire to measure emissions associated with their projects. In terms of barriers for clients, number 1 was insufficient interest at a management level. So even when, some people within organisations are really keen to push through sustainability, it doesn't go right up to the very top. And another one that rated really highly was that because we are not including sustainability in our standard scope of works, they're not asking for it. So now on to the main topic for today, which is these low carbon resources, which SESOC are making available to all of you. So where can you find them? If you navigate your way to the SESOC website, you'll currently find them advertised on the news banner, but where they actually live can be found under the design resources pages, and there is a special page for sustainable design resources, which has lots of different resources and now includes our top tips and roadmap. So this is what this low carbon design resource map looks like. There's 2 versions of this map, and this is the PDF version with all the links to our top resources off to the right. And these have been grouped by category to help you find the ones that you need at different stages of design. There's also an interactive version, where if you click on the numbers as you make your way down the river, it opens up the links to the different subtopics. The other resource that we are going to be referring to today is our top tips for low carbon design. We started with 20 and ended up with 21 top tips. Again, these have been organised so that you can progress through them as you progress through your design. So we've got some high-level overview ones, 1 to 4, then getting into influencing the system, influencing the detail, and finally influencing the build on site. I really encourage you to jump onto the site and download this guide. Each of the tips is only 1 to 2 pages. There are lots of examples, images, really easy to read and digest. So yeah, now we will get on to some examples of where the team have put these top tips into practice. So first up is Jared. Welcome, Jared.
Thanks very much, Lisa. I'll just check I've got this working. All right. Hello, everybody. So my name's Jared. I'm with Beca, based in our Christchurch office. And I'm going to be talking through, for my case study, one of the top tips with a few different examples of how we've gone about communicating the impacts of carbon on projects in the past. It's kind of a core part of what I spend my time doing. So when I look at communication of carbon, I think there's a bit of a different range of how we go about doing it, from the more comprehensive and complicated through to the faster and simpler. I'm going to talk through each of these. I'm going to try and focus a little bit more on the simpler ones because I think they're more useful for us day to day, but I will start with some of the more comprehensive ones. And so that tends to begin with full formal whole of life cycle carbon assessments. And for those who haven't perhaps seen what they look like before, they can be reasonably comprehensive reports. They cover all sorts of different things in the building, where the carbon is found, what you might be able to do about it, some strategies for reducing it, upfront carbon, whole of life carbon. They will go into some clarity around the scope of the assessment, which elements are being looked at and which stages of the life cycle are being looked at. Provide a breakdown by element of where the carbon might be in a particular building. They will also typically look at a lot of other environmental drivers and delve into those, and they will contain pages and pages of calculations and data to justify where those numbers come from. In terms of communication, these to me are extremely useful in formal situations. So when we've got clients who might need to report back to boards or ministers or executive teams, this provides the serious technical rationale behind carbon numbers that they can use to justify financial decisions or perhaps use to obtain certification and so forth. So very useful in those formal situations. A bit more cumbersome in day-to-day design discussions because they can be quite big reports. It can take a little bit of time to put together. So when we delve into what we might do day-to-day on projects, we've got a few examples that can be rolled out far more readily. This particular project here is Waimea School, just outside of Nelson. It's a two-storey timber building for the Ministry of Education. Those who have worked on MLE jobs might know they've got some pretty trim budgets, and they can need a bit of justification to do something different. So for this particular project, we had a reasonably sympathetic project manager on the client side, and we pulled together this document here. It was a 3-page document in the end. It's really a simplified version of what you might see in a full carbon assessment report. It contains the headline numbers. It contains the savings that can be made by going, in this case, to a timber solution compared to a traditional steel and concrete solution. And it helps to sit alongside some of those early decision-making processes where we're comparing costs, but we can also compare carbon and usability and all of those things. It was very useful for our particular client to help get this across the line in a far less formal way. It's much faster to produce this. Important to note, it doesn't have the level of rigor and robustness that you would need to get, say, something like Green Star certification. It's still very handy. As we delve down another level, into a faster approach again, we get into comparative studies. And this is something that I think many of us will be doing often on projects. This particular example is a slightly larger building. It's comparing a moment frame versus a braced frame on a base isolated building. And I would like to think that many in this call will be able to look at these two systems. They will know that moment frames are going to be less materially efficient. They're thus going to have more carbon associated with them and would be able to convey that conversation relatively easily. I think part of the challenge that we have as engineers, though, is that we can carry a great deal of influence and mana often in design team discussions when it comes to life safety, when it comes to resilience, but we don't perhaps have that same natural influence when it comes to carbon. And so what we can do is put some hard numbers to that. Because people trust us when it comes to hard numbers, they rely on us for hard numbers. And we can, for instance, in this case, point out that the structural framing in the moment frame option carries about 150 kgs of carbon per square metre. Put that in front of the design team, have that discussion. And we tend to find this is quite a strong way to influence the directions of discussions, to put these hard numbers out there and set it alongside. So I would encourage everyone, when you're doing option studies, as you may well be doing for cost purposes, to also put a carbon overlay on it. It's a relatively straightforward calculation to do once you've already got those materials. The other type of work that we all often do is seismic strengthening works. And top tip number 5 talks about adaptive reuse, which is really seismic strengthening through a different lens. This particular building here is B201 up in Auckland. The big building at the back is a seismic strengthening scheme. What we did on this, largely because we had a client who was very interested in it, was convey the carbon savings that went along with that seismic strengthening scheme. In this case, it's about 3,000 tonnes of carbon compared to a new build. It's a very, very substantial amount of carbon. And we often find that seismic strengthening schemes can offer these very large carbon savings by comparison to new builds. And I would encourage everyone, because I think it's something that we as an industry don't do anywhere near enough of, to also convey the carbon lens on top of any seismic strengthening schemes, because it is usually extremely beneficial, and something I'd really like to have as part of the kind of common language of our industry about those benefits. The last communication example I have is quick advice. This and this is to me a really important one, because it's something we should be doing all the time. So this image here is a project for ag research just outside of Lincoln University. It's the slab on grade for a glasshouse, and the 4 little things you can see across it are point drains. On this particular one, we had a look at the drainage system, and this is an email I sent to the client saying we had slot drains in here. Those slot drains were associated with quite a large concrete screed. If we went to point drains, we could get rid of 130 mil of concrete. That works out to be about 9 tonnes of carbon. 9 tonnes of carbon is about what you or I have budgeted for ourselves for a year as citizens of New Zealand. Would you like to get rid of all that carbon by going to point drains instead? The client received this email, gave me a call back. First thing he said was, Jared, what sort of training course have you been on to turn into a raving hippie? And then after he said that, he said, look, let's do it. And it was a pretty quick decision for him. There was no cost difference, massive carbon saving, and just through a simple piece of communication, we could get some pretty good outcomes. And I think this is the sort of thing that we can all be doing all the time if we just put in what in this case is about 2 minutes of effort for a calculation and about 5 minutes of effort to send off an email about it. And so I'd encourage everyone to think about how they can do similar simple things in their design. The last thing I was just going to quickly highlight, because I think it's particularly important in these top tips, is if you don't have the time to read the whole thing, or even to read bits, and it is a very easy document to read, there are these examples posted through it, which I think are very valuable. A couple of ones I quite like. There's a bit of benchmarking data around what the Ministry of Education have been doing. It's very hard to get that benchmarking data. So it's really good when those examples are out there. It can be very useful for us all to have those to be able to share with our clients. And similarly, there are some good comparative studies that have been done, in this case, one by Bureau Happold about closing up grid spacing. We can all do these comparative studies ourselves, but we don't normally have time. So just having the results of some of those readily available can help give us some good guidance. And my favorite example is this, just some simple numbers that convey the amount of carbon associated with different materials. But it wasn't until we started doing the top tips that I started thinking about what on earth do these units mean. And they're in kg CO2 equivalent per kg, which is a pretty strange and unusual unit. But to me, if you take a kgs per kg unit and you think about the particular material that you might be using on your current project, whether it's structural steel or concrete with reinforcing steel or even timber, you can convert all of these to kgs per kg. And you imagine all of that steel or that concrete or whatever material it is up in the air. And you imagine that there is a multiplier on that total weight of steel, which is the CO2 equivalent associated with getting that steel manufactured and in place. And all of that CO2, as a result of you doing that work, has now gone off into the atmosphere. It's pretty tangible and it's pretty visceral and a bit scary, I think. And the sorts of things that if we think about and we share these sorts of numbers with others, I think can really change the way that we go about doing our design. And so with that, I'll pass over to Rob to explain how he's gone about taking account of that on some of his designs.
Thank you, Jared. I'll just try and manage this transition. Good afternoon, everybody. Thank you for coming online and taking part in the conversation, which is only going to grow as the years go on. Robert Lade is my name, from Lewis Bradford Consulting Engineers in Christchurch. I think it's important to caveat at the start that I don't lay any claim to be an area expert in this. I've just been dabbling over the last year or so and trying to understand the ever-growing quantity of information out there in the sustainability and carbon field. Basic proposition for the next 10 minutes or so for everybody here, from my point of view, is a lot of what we're talking about and are going to see, it's not new. A lot of it, you might agree, when you read through, particularly all the top tips, could form part of what we aspire to as good designs. We've all had designs that have just fallen out with efficient grids, it's clicked well with the architect, you know, and you'll find that you end up with less material. And conversely, you'll have plenty of designs where you're backed into a corner and have to do structural gymnastics, of course. The other aspect to consider is carbon counting is coming. It's not clear exactly when, but it is something it's going to be bestowed upon us eventually. And from my bits of dabbling, the basic calcs that we might need to do as structural engineers, not all that complicated to do. What struck me reading through the top tips in particular was, yeah, it's not all new. A lot of it's good pragmatic advice that we should hopefully be following on any good design process. And it's always good to get a reminder of these things. So this document is just another one of those things. So nothing to be put off by. I think what's really interesting, and we have benchmarked a lot of our buildings we've designed in the last 10 years, in the last year or so, to see where they're sitting in this carbon world, and they generally range along the numbers you see on the screen here, about 250 to 750 kg CO2 equivalent per square meter. And there's plenty of literature growing out there for how you can add up all the carbon. But what's probably more interesting is how can you set up your jobs from early days to arrive at a lower carbon number when the calculation, when the detailed numbers are finally done. I think that's where structural engineers in particular can have a lot of influence, and it's just, you know, arming ourselves and going out and doing it. So I'll try and talk through two quick examples where we've arrived at, you know, pretty reasonable carbon outcomes, but we didn't approach them specifically with that in mind. And again, that's just talking to an outcome of what I think was a good design process. First one is the Youth Hub, which is stage 1 nearing completion in central Christchurch, a very rewarding project aimed at improving the lives of young people. And young people were part of the design process, and climate and climate anxiety were things that came up through that. And one of the outcomes of that was there was a desire to design a building, development that partially seeks to help address that. So from a carbon point of view, there was already a clear driver for this, which helps. Some of the things we actively did, very early on, we set it up, you know, one of the buildings on a very traditional steel grid, concrete floors, ribbon infill, K-frames, bread and butter. We knew that would be relatively low cost. When the discussion of embodied carbon came along, we had a good chat with the architect around, well, if we want to go down a lower carbon route, that probably moves us more towards engineered timber. What we didn't want to do was just apply a timber frame over a steel grid, because you get quite large members and it's not as efficient. So we said, hey, can we look at tighter grids here? And in this case, they were totally on board. After that conversation, came back the next day and said, hey, Rob, how about a forest of columns, which is what we actually ended up with. And that helped us keep all the member sizes rational. So in terms of the top tips, upfront coordination and really test, you know, can we have tighter grids and more columns? Is that detrimental to the building? You won't always be able to have tight grids, of course, but in this case, it was feasible. Back when this was being designed, we weren't ourselves doing any carbon calcs, but the architects did have a look at it, and they prepared this as part of some of the concept work when we were looking at two options for the building. So they did do some calculations back then, which is good, and there was a reasonable saving going down the timber route. In the last year, we have started doing some of these numbers. If we were doing them now, might look something like this. You can take those numbers Jared showed earlier, multiply by, you know, just the mass of the material, which we all have most of it already from our seismic weight calcs, so it's not much new information. And just pick up these four numbers on top, and you can very quickly get a total carbon number. Divide that by floor area, repeat for each of the main materials, and you can pretty quickly get the numbers you need. I mean, the point here is it's pretty straightforward to do a rough and easy number, given we have most of this information already. For Youth Hub, we did communicate the impact of going down one scheme or the other. I think it's important to recognize, particularly when going down some of these low carbon schemes with timber, it's a whole design team journey, not just an engineering only journey. There are knock-on effects for other consultants going with, say, timber structure. So it's important to lay that out. On the right there, you'll see a scoring system. We don't have a system in New Zealand that we've agreed upon yet for how we could rank our buildings. I've just shown if we applied the UK system, where the youth hub might come out, and by going to an all timber solution, it does fall out reasonably well. Some of the things we did on the job to help that timber scheme stack up early. We scheduled out all the timber elements, quick phone call with Timber Lab. They were very happy to provide a quick cost estimate the next day based on the schedule. We were able to provide that to the project QS. They could build those numbers into their budgeting. So we had a reasonably realistic cost, high level, early days of what the timber scheme might look like, which meant the QS didn't have to put overly high risk money on that, which we can see happening from time to time. Important thing to remember when you are going down that kind of timber route is that tag number 2 you'll see on the right hand side is the metalwork fixings or the connection bracketry. This can be a pretty large cost component of that scheme, so it's important to make sure there are good allowances in early and it's not overlooked. The setup of the building itself, we tried to keep it pretty simple, particularly with that tight grid of columns. By keeping the timber frame as gravity only, we were able to keep the connections very, very straightforward. And the geometry of the building, tight floor to floor heights and lots of walls meant we were able to do SCD plywood shear walls throughout, which allowed us to get a bit of ductility in and helped with the foundation design as well. So the whole thing fell out reasonably smart for a kind of a low carbon system. Just talking to some of the other top tips. Timber floors, the tip there is know how to make a low carbon flooring system work well. I can't claim to know how to do that, but I know there's lots of challenges that need to be worked through as a team. It's probably straightforward for us as structural engineers to design beams and floor joists. That's relatively straightforward, but there are fire considerations, acoustic considerations, and all those have to be built in from a cost and carbon point of view. So the point here is we're aware, just ask questions, get the design team engaged. It's not just us as structural engineers that have to answer all these questions or problems. And then some of the other top tips we did do on Youth Hub, kept the concrete strengths relatively low, which is a good win. Didn't overly dictate to the concrete supplier, let them optimize for lower cement. And one email, pretty easy to ask for an environmental product declaration. So we did actually do that. One more quick example. We'll all see portal frame buildings all the time, single story school. Traditionally, that would just be steel purlins and UB columns and rafters. This school in particular was part of the ministry's embodied carbon assessment trial. So we were engaged to look at options early days and very quickly just to pick out one structural bay that is going to be repeated down the building, mock up some very rough member sizes, and you can get the weights, multiply by those carbon numbers, and very quickly compare where savings can be made and help to steer that conversation very early. And again, on this one, we did do the numbers. I guess what was interesting when we did the numbers and why it's worth doing the numbers is while the primary timber frame itself is very, very low carbon, the majority of the building is a floor slab and a roof. And we did have quite a lot of cross bracing in the roof, and the floor slab is concrete. So the overall impact of having the primary timber frame isn't that significant. But it was quite interesting. Just you can't get that unless you do the numbers, is I guess the point. So it is worth having a look. And yeah, just to wrap up, not all new. Let's try and use sustainability as another tool to drive better overall design outcomes as a team. Those basic upfront calculations are relatively easy to do. We have a lot of the information already. There's just a couple of new numbers to add on. And can we early days move the needle towards lower carbon outcomes? So that's me. Thank you, and I'll hand over to Nick. We'll pick up from here.
Thanks, Rob. Great couple of examples there, and some good dialogue from your journey in this space so far. So thanks for that. Kia ora, everybody. My name's Nick Carman. I'm just going to get these slides working. Here we go. So yeah, my name's Nick Carman. I sit in the buildings team here in Mott Macdonald in Auckland, mostly working on quite large scale projects, but occasionally do get the opportunity to play with some smaller projects, and I wanted to profile one of those today, which is at a pretty small scale, at a single residential dwelling scale. So just going to briefly take you through sort of some of the basics of that project and how we brought carbon in to the way it was developed, and how the top tips from our low carbon guide are represented in some of that work. So that's the site. This is the basic brief for the building, including the brief came with this diagram, basically part of it, which was seeking to not operate on just a time cost quality traditional project management triangle project outcome model, but include carbon as a key metric to track as part of that. So it wasn't about creating the most, it wasn't about creating a lowest carbon house. It was about being cognizant with the carbon spend and running that as a metric or a lens over the options. And this project, I think, hits quite a number of the top tips from the guide. And I've highlighted the first 4 because the way the design process ran, we were cycling through top tip 1, 2, and 3, and 4 as we looked at different options or different either challenges or opportunities came up. So that's really where you're kind of doing, our traditional iterate between a few different things to find what the right solution might be, but being open and communicating and coordinating that with some of these, as Jared put it, hard numbers that we can bring to the game. Was a key role for us on this project. So, as you saw in the brief, 100 square metres maximum. Unsurprisingly, the first scheme came through at 100 square metres. First, one of the first things we did was run a design carbon check on that. Necessarily had to include some of the wall and ceiling finishes as part of that, where they were either part of the structure or just as finishes, and of course the building envelope as well. So this is a whole of building embodied carbon check, not just the structure, but superstructure and substructure obviously captured as part of that. So okay, and then through a combination of COVID cost escalation, time, and a couple of other things, there was some value management undertaken. The building was shrunk from 100 square metres to 80 square metres, and from 2 level to single level, and considered at using fairly traditional systems for that. Okay, run the carbon calculator over that again. What does that start to look like? Well, interestingly, the sorry, just 1 second, team. Sorry about that. So the whilst the carbon per square metre actually went up by 5%, the total amount of carbon associated with the project went down by 5%. So we thought, oh, that's interesting. Need to make sure we're keeping an eye on both those metrics, don't we? All right, good. Lesson learned. Let's keep moving. The pie graph on the left also highlighted that there was this very large percentage coming through as part of the construction process of the building, which is a bit unusual. Wouldn't normally expect that to be sort of more than 10% for the larger projects that I typically work on. So we delved into that a bit, and that was partly coming from duration of projects. So as you saw, the project's a little bit out of town, so an increased amount of worker transport over a 12-month period. And then because it was sort of traditional timber pole, concreted into the ground, and for the site and the steepness and dig operation for that, there was actually quite a bit of diesel burn associated with that. So went back, said how could we get rid of that, found an alternative steel ground screw system that was appropriate enough for a single level building, that reduced the foundation install time quite significantly, and went to more of a panelized floor system, which also brought the program in quite a bit and knocked back some carbon out of that construction period, kept the net total embodied carbon outcome on both an absolute and per square metre basis quite similar, but improved those time metrics for the project. So moving through, this is pretty well what's on site now in terms of the overall system and configuration. It's an engineered timber platform with effectively a 3604 house on top of it. So now starting to hone it, looking at just the structure again, which is about 40% of the total of the building, and identifying that really that long-term stored carbon that's in a lot of the mass timber. That was partially the consideration around how to long-term stored carbon. So how do we maximize the storage of that carbon, maximize the life of the building? That's partly why a more intensive envelope in terms of the metal cladding for the building's been selected, trying to maximize that benefit for both the building and the atmosphere for a period of time. But you can see that the foundation system contributing a fair amount there. And just wanting to give people on this call an opportunity to look under the hood of how these numbers are generated. It's not incredibly sophisticated. It's structural material weights times some factors that are embedded in some trusted calculation tools. This is the NZGBC one, but I could have been using OneClick or eTool or the Brands tool. And all of that analysis that I've just been through comes from literally 10 line items of information, 10 materials that just needed a quantity or weight number associated with them, and a good enough matching selection to them in the tool. So yeah, really low effort, but yields a lot of interesting information that you otherwise just do not have as part of the decision-making process as part of that. And then we calculate, communicate, coordinate, and we sort of run that through. I just wanted to touch on something that's a bit more familiar to me in terms of the day-to-day of what we work on here at Mott, something literally 150 times bigger. Is that 100 times the effort? Nah. That's also a materials list of about 10 items. Okay, there's some reinforcing rates there associated with each of the concrete items, so maybe it's more like 18 line items, but still that's a 13,000 square meter building at a sort of 50% prelim design level, captured through a fairly quick exercise of structural material quantities that we have to be looking at anyway for our seismic analysis and other things like Rob pointed out. Chuck it in the tool and run a similar exercise. You're just doing it for something much bigger. This is just an example of just putting in front here a couple of things that we looked at for that house that we didn't adopt. So we started off thinking that we had to go all plywood everywhere as much as we could, but in a few instances, the jib lining started to come in as an option for the client, and then actually quantifying how much carbon impact that had. We were surprised to see it wasn't actually that much. We did have a discussion about timber to steel start at one point and discovered that was quite a big potential impact for the carbon as well. So that was shelved pretty early on. But just looking at these things across as a holistic exercise, not just from one metrics perspective, but from multiple. And just a few shots to show that it's not just a render, so putting in the screw piles very quickly and run off a lead to the site power, no fossil fuel burn involved, except for the truck to get it there. House going up, CLT platform down early, plywood skinned, enclosure up very quickly and nice and stable, very little temporary works, roof on, weather tight in 3 months, and client happy to enjoy what they're starting to feel like as a finished product, without having to think about the engineering, but knowing that a process has been run that's met that part of the brief in terms of optimizing those different metrics. So yeah, just to recap, I won't go through all of this now because I've touched on it, but just to show that a small amount of work can actually yield a large amount of impact on many items that are contained in the guide that we think is very relevant to what many of us are doing every day. So open it up, have a look, start playing with that calculate, communicate, coordinate loop, and enjoy learning what you learn from that process, because it can be really interesting. That's it from me.
Kia ora koutou, ko Phoebe Moses tōku ingoa. I'm Phoebe and I work at Beca as well. So I'm in the buildings team. I was a structural engineer for quite a few years, and then almost 2 years ago, I moved to a full-time role providing carbon assessment and advice to clients on buildings. But still, not only dip my toe in the structural engineering world, but as has been demonstrated throughout this presentation, you cannot really get away from structural engineers if you're trying to reduce carbon in buildings. So I work alongside and collaborate with structural engineers every day to try and figure out how we might go about these carbon reductions on buildings. So I'm going to fire through our final case study for today pretty quickly. So the project I'm going to share has only just finished concept design, so it's still pretty early stages. But we've actually been doing quite a lot of carbon thinking for a while already, and I'll touch on why that is a little later. I'm really just going to run through, I guess, a few of those more early stage tips, and also touch on why it's never too early to think about specification and the implications on the project process. So we were first put on in the pre-concept, so thinking, business case, SESO stage for the client, and that was primarily because they wanted to understand the implications on what the building looks like to obtain 5-star or 6-star Green Star. So I'm not sure how many of you on the call have worked on a Green Star project before, but one really important thing to understand is that if you've worked on a Green Star project before the beginning of last year, it looks really, really different now. The version of Green Star that we've got currently requires mandatory reductions in upfront embodied carbon in order to even achieve Green Star. And what that reduction looks like is different depending on the level of Green Star that people are seeking. So in this instance, the client was wanting to understand what a 5-star Green Star building might look like and what a 6-star Green Star building might look like. So the structural engineer sort of threw up a few options, and we did a quick assessment on that just to compare at a very high level what those likely carbon outcomes would look like, and through that, how difficult or costly it might be for those different buildings to achieve the 5-star or 6-star Green Star certification that the client was looking for. So that's sort of the broad project context, and that really falls into that integrate carbon management. So make sure you're aware of any particular drivers that the client's got around upfront carbon. So understand if they're seeking Green Star, understand if they've got any organizational requirements to report on or reduce those upfront carbon emissions, because although it might not be you who's in charge of doing the formal assessments, so those really formal LCAs or life cycle assessments that Jared was showing, that doesn't mean that you're then absolved of responsibility of taking action and trying to figure out how to reduce those carbon emissions. It's a project team-wide responsibility. We then got into pre-concept, from pre-concept, and this is an opportunity to influence the system. So again, keeping the carbon assessment at a pretty high level, looking at the building as a whole, tried to figure out where some of those carbon hotspots were, where most of the emissions were coming from, and if there were any opportunities to reduce. And we did highlight to the client at this stage that for this particular project, the foundations and basement were responsible for almost 40% of the whole project embodied carbon emissions. Now, it's not just structure. For this building and for Green Star, that encapsulates also your envelope, your fit out, and your building services. So the structural foundations and basement alone being responsible for 40% is pretty significant. So, a real option to focus in on, and maybe even figure out if we can remove some or all of that basement. So there were a lot of conversations and design optioneering that went through over the next few months. And long story short, the good news was that the project was able to reconfigure the building, some of those key functional areas into other parts of the building, adding some floor area above ground, and also reducing the total ground floor area by removing a basement level. And that resulted in a 10% carbon reduction overall, which was not only just a great win for carbon, but also gets this client a significant amount of the way forward to some of those mandatory carbon reductions that they need to achieve for their desired certification. So really quite a big one quite early on. We'll then get into concept design and the client's wanting to understand some more of the options around the floor for the tower aspect of the building. And you can see here, it's just sort of very quick, 2 different framing options, 2 different flooring options. How do those combinations look in terms of carbon, in terms of the whole building? And what's interesting to note here, and again, you know, to Rob's point earlier, sometimes you just don't really know these things until you do the numbers. So although there's quite a significant difference for your starting point for what those different options look like, as soon as you start thinking about options of procuring lower carbon or sort of green versions of materials, those sort of lower options start looking a little bit more equitable between the different strategies. So just because you might be forced down a, you know, nominally higher carbon route for your project, that doesn't mean that you're then devoid of options to further reduce carbon. And so unfortunately for this aspect, the client did select to go down the highest baseline carbon option. However, they've done that with the intent, the explicit intent to intentionally procure lower carbon materials. And that brings me to my final point around specifying well. So obviously, you know, if you're relying on a certain material specification to achieve a lower carbon outcome, you want to be all over that from a very early stage, because that's quite a high risk strategy unless it's well managed. And as structural engineers, you can really help de-risk that for your clients through having, you know, a good understanding of your supply chain and the transparency around that and the cost around that as well. So, you know, what materials are precluded from, you know, being used in New Zealand because of their structural performance. They don't meet our seismic requirements for ductility. All those sort of things feed into the whole carbon picture that need to be taken into account at a really early stage if someone's going to be relying on procuring low carbon materials. So again, we're only at concept, but we've already had a number of conversations with the quantity surveyor and client and structural engineer to try and come up with a project-wide strategy to reduce it. So again, only at end of concept, so still a wee way to go, but yeah, so long as we keep integrating carbon management, not only at the beginning here, but we keep coming back to it at all key project stages, we should be able to manage those carbon outcomes. I'm also just going to share the task force next steps. So you've heard from 5 of us today. We're actually quite a big group, and we also don't want it to end here. This is not our last hurrah and we're leaving. We've got more to give, and one of the first cabs off the rank, and this is as a direct sort of response to the release of the guide, is the request for some more worked examples. So in the similar vein of what we've shared here, but perhaps in a bit more detail, breaking down how those calculations are actually undertaken on a project. We've currently got a couple of working groups going through 2 different worked examples, both for sort of a small, medium scale project, just to demonstrate in a bit more detail how that can actually happen, and hopefully that will help other people figure out how to set those up for themselves internally. Another part of our, I guess, core role is trying to make sure that structural engineers are aware of the context in which they're operating. So as I mentioned before, you know, that one change in Green Star suddenly actually means that structural engineers are bearing a lot of the burden of achieving a client's desired outcomes in a carbon space. And it's not just Green Star, you know, we've got MB Building for Climate Change. We've got a whole host of other external pressures coming onto our clients in the carbon realm that we need to be aware of so that we can respond to it and price in any additional work that we need to do in order to demonstrate to our clients that we're you know, meeting their particular targets there. Thirdly is benchmarking. So we're very aware that you know, as Rob mentioned, we're currently still looking to overseas benchmarks to try and see, you know, where is this project sitting? Is it good? Is it medium? Is it bad? We don't really have what those numbers look like in New Zealand. So, but collectively, a lot of structural engineering firms have done a lot of these assessments internally. And so if we pull all of that together, we should be able to come up with some really robust baseline numbers that we can all look to see what's normal, what's good, what's bad. And that's, again, hopefully going to happen over the next 6 months to a year. lastly, material data. So we've provided you in the top tips guide the 4 values for the 4 different materials. But some of the feedback we were getting through the survey and focus groups is really that structural engineers don't necessarily feel like that information is provided in a transparent way, particularly if that's coming from, a particular material industry. So that's something we think that both, leaning on the brands and other carbon databases, but communicating that in a more simple and reachable format to structural engineers is something we're quite keen to do as well. So this was the task force that delivered the guide and resource map to you. So we, I guess, represent quite a wide cross-section of the industry, and we're also growing. So these are 4 new members who've joined us in the last few months, and really hoping to keep delivering what you're looking for. And with that, good afternoon, and we will jump into some questions. So I'll pass back to Lisa.
Well, thank you all for sharing those case studies. It is really awesome to see how many people are diving into calculating embodied carbon on their projects and some of the learnings you've had from that. So we have had some questions come in. If you want to ask a question, you should be able to find the Q&A button at the bottom, and remember, you can upvote the questions that are there already by giving it a wee thumbs up, and we will try to answer those ones first. The first one that's come in is for you, Nick, and it's around whether your calculation of carbon is just embodied or if it includes those life cycle carbon costs, such as the operation of the building. This was something we haven't really discussed in this webinar.
Cool, I'm happy to answer that briefly. So in short, yes, operational energy and operational energy converted into operational carbon impacts was looked at as part of the project. I've got a whole other slide with like heaps of detail about that, but in the interest of time, I haven't included it. Suffice to say that that project, although consented before the later stage 1 changes came in, one of the studies we did was on the benefit of meeting that anyway, demonstrated there was a benefit. So I think you saw that the structure was about 6 tonnes of carbon upfront, embodied carbon for the construction, kind of getting it to open day. It's about 1/10 of that per year for operational energy / operational carbon prediction. So it was looked at as well. And some of the thermal break or thermal bridging reduction detailing that we built into the external walls was kind of informed by that as well.
Awesome, thank you. I think it's important to note that in the top tips, most of the time we're focusing on the embodied carbon associated with the structure, but we do need to look at this holistically with the rest of the project team to make sure that we are capturing that full life cycle of the building. The next question is also with regards to your project. And you mentioned that you were looking at the net carbon, but also the carbon per square metre, and that when you reduced the size of the house, there was a reduction in net total carbon, but the intensity per square metre increased. Do you think if the house was then renovated and the floor area extended later down the track, that would change those ratios? Is it a function of house size? Like, is there a magic ratio?
I think the sort of heart of that question is building a bit more now than what you think you'll need versus kind of trying to optimize what you build now and then add to it later. There's always some sort of numbers that need to go with that, because it'll depend on what materiality you're choosing for the build piece now versus the build piece in the future. Carbon intensity of materials in 10 years' time might not be the same as what it is now, Ideally, if you listen to the material suppliers, roadmaps for reducing the carbon intensity of their materials, supposedly we're going to have lower intensity steel, concrete, and timber in the future, at some point next decade and out to 2050. So that's probably something to think about as part of that. But overall, the kind of try to optimize what you need now is I think what the study on that project partially showed. Yes, the intensity per square meter went up by 5%, but the overall absolute carbon, which is what the atmosphere cares about, went down by 3 tonnes. So yeah.
I might just add to that, if I may.
Go for it.
So all excellent points, Nick. Also, you might recall seeing in Rod's second example, the surprise around, even though they reduced the framing a lot, because it was a sort of single-story warehouse or portal type structure with a big concrete slab at the bottom, and the slab and the roof were quite intensive. Those high carbon items, obviously, if it's a single-story building, will only be shared over that floor area of the single story. If you keep the same floor area but make it a 2-story building, and say you only have one slab on grade or one set of foundations to support that floor area, that it can reduce your both your total carbon emissions and your net. So you can get some efficiencies going to a 2-story instead of a single story. Obviously, that depends on your subsoil conditions and the building functionality itself, but always worthwhile looking at that option as well.
And I think all of that just highlights that we need to actually do the numbers. Quite a popular question, which I'm going to direct to Jared, is how do you ensure that what you specify is actually carried out on site?
Good, I was just reading that one. I'm glad you directed it to me. I think in some ways it's quite easy, right? I mean, it's effectively a quality assurance thing in the same way that we have a responsibility to make sure that all of our structural requirements are done on site. So the simple way for some of these things, for instance, concrete material specification or something like that, is through EPDs, which are effectively used as a form of structural QA documentation when there is a carbon requirement on the job. We need to make sure we specify these things properly and correctly in our documents, and so there's guidance in the top tips around that, and then we need to make sure we follow up as we would say for following up that welds are appropriately checked on site in accordance with our specifications. If we're specified that things need to come from a particular mill, or if we're specified that the maximum global warming potential of concrete is X, we need to provide within our specs some requirements around what evidence is going to need to be shown by the contractor, or we need to be doing our own construction monitoring perhaps to be checking that. So ultimately, I think it's just the same as anything else. Slightly different tools, slightly different knowledge to get there, but the process, I think, is very similar.
I just add very briefly, I think another point, Jared, maybe is if we're going to specify something, let's engage early with the industry and make sure they can deliver it, or at least we have a route to it being delivered. That way, when questions do come, we've got good responses. It's beholden on us to make sure, I think, to a degree, what we're specifying is going to be achievable. And if it is difficult, everyone's aware there's a bit of difficulty to work through, but we're happy to work through that difficulty so it doesn't just get slashed later.
Yeah, totally agree, Rob. I mean, there are not all, but there are, I would say, many concrete suppliers who are quite actively engaged in this. For instance, they would love to get phone calls and say, what can we do? And it's different in different cities, right? So you need to talk to your local suppliers and understand what they can do, and you need to talk to your client and understand quite how much competitive tension they want to get. But at that point, once that decision's made with your client and with sufficient knowledge of what can be achieved, it becomes a contractual requirement ultimately.
Great, we're going to move on to next question. There's a few here around using timber. A few of the projects, the case study projects, used timber. So there's one question about when you incorporated timber in your calculations, how did you deal with the biogenic carbon? And then a follow-up to that, if you are, using timber, do you need to ensure that timber comes from a sustainable source, forestry with plantation programs, etc.? So I might pass this one to Phoebe.
Kia ora. So I believe all of the examples would have done what is we recommend in the guide, which is to not include the biogenic carbon storage in that total number, but to still calculate and demonstrate it as Nick did in his example, sort of off to the side as a long-term carbon storage. So that is both the approach that Green Star recommends and also the approach that I guess, yeah, SESOC takes, is to exclude the negative part of timber from your overall number, but to still demonstrate it over to the side as a potential benefit. And the second, your point, yes, absolutely, it needs to come from a sustainable forest managed source, or at least from a country you can be sure that that is happening, even if it doesn't have the necessary certification. For example, New Zealand. And I will refer you also to the SESOC journal article on timber and carbon, which runs through pretty comprehensively, which Lisa and I worked on alongside Katie Simons from MB, all the things you need to know about carbon and timber, including the answers to both those questions.
Thanks, Phoebe. I think the other key part of that reporting separately is that it acts as a communication prompt for people around, okay, well, how do we ensure that that those elements stay solid and stay providing that storage for as long as possible, and potentially even after the building stops being whatever the building is on day one. So yeah, reporting them separately is really useful for generating that conversation as well.
So there's a question here about New Zealand's energy becoming more green. So as the greening of the grid is happening and electricity gets less carbon intensive, are some interventions intended to reduce life cycle carbon doing more harm than good? So should we be focusing more on upfront carbon emissions now that reduce that carbon released into the atmosphere now, versus adding more carbon to our designs for long-term reduction? For instance, adding more thermal mass in concrete structure or aluminium louvers to provide shading.
I can comment on that perhaps if you like, Lisa. I think yes. So as we do have, or we already have quite a green grid, right? And it's getting greener. And by comparison to some other countries, ours is quite green. So I think for me that means we have even more emphasis in New Zealand on embodied carbon, on the structural carbon, if you like. For me, how that often plays out in projects is we'll often come into projects where they want to put some PV panels on the roof, and they want to say they're going to do that, and then the building's going to be green. And that can often be a useful prompt to say, well, actually, do you want to do some quick numbers and understand where you could make some real carbon savings? Because when you do those sorts of savings on, say, specifying your concrete slightly differently or something like that, it often shows that the embodied carbon is much better in New Zealand than some of the things that people might be doing. I think that does mean that some of the solutions that are used around the world, like say making more use of thermal mass, are less applicable here. I think if you've already got some concrete there and you're going to have it and you can make use of it in a useful way to reduce operational carbon, then cool. But I wouldn't necessarily be going out of my way to frame up a building strategy around that if it came at the expense of something else. So I think you do need to understand, and again, that's part of doing the numbers on that and doing the numbers specific to your project, right? Understand where those numbers come from and making adjustments as things change. I think perhaps even more significantly than changes in the grid is changes in the manufacturing process around some of our materials that, when they hopefully eventually come in, will change some of the fundamental numbers around embodied carbon, and that will then have knock-on changes to how we design buildings.
Great, thank you for that. Another question, which is quite popular, is around benchmarks for different building typologies. So how close are we to having sufficient data in New Zealand to have our own benchmarks for what a business as usual typical building looks like in terms of embodied carbon?
I'll take that one. Current status as of today is that we're still quite some way. We currently lack a national method or system or database or infrastructure or platform, whatever word you want to use, that some countrywide body has set up to provide a pool for putting verified and approved assessments for this into, and then creating benchmarks from that, from looking at that data. The scale required of the whole building level or significant parts of building level assessments that would be needed for that is, to set mandatory nationwide minimum caps, there are thousands of data points that want to be collected for that. So that's, in my opinion, going to take some mandatory reporting requirements in order to generate that amount of data. So that is what many of us are hoping to see come into play. So because if we go setting benchmarks without that, we're throwing a dart in the dark, So yeah. Watch this space. There's lots of people trying to make it happen. I'll say that as well.
A second part to the question, Nick, is around whether New Zealand's seismic design parameters make this too hard. And I take that question to be like, because we have different seismic hazards over different parts of the country, do we think this would change benchmarks depending on where you are?
Oh, yeah. I mean, collecting the data is absolutely going to have information about building typology, building scale, seismic hazard that it's been designed for, performance that it's aiming for, high floor vibration requirements or not, which can massively influence the floor plate, which is a very large part of the carbon. What kind of ground are you on? Are you on bad ground? Are you on rock? All of those things are going to have a carbon to variable relationship. So it's not just a GFA and carbon number that needs to be collected. It's describe the basics of the building and the carbon number, and that's what many of us are seeking to have happen. But and that will ultimately require design teams to step in and provide that information.
Cool. We've got a question here about whether there are any different tips that we would give for infrastructure projects, because the low carbon design, the 21 top tips, are really focused at building projects. Does anyone want to suggest some additional tips that might be relevant for infrastructure projects?
I would say the task force, and actually SESOC generally has a wee bit of an emphasis towards buildings. So we would we probably would openly invite some involved in the infrastructure space to share their thoughts. We do have Jamil Khan, who's on the task force, but not on this call, who might be able to provide some follow-up thoughts on that later. Certainly one of the things they do get involved with is looking at design lives. They have much more thoughtful discussions around those and are designing for much longer periods and want their infrastructure to last a very long time. But some of the rules, things like specification and so forth, I think apply pretty well.
I won't offer any specific tips, but I'll just say one word, which is civil. Well, a couple of sentences, which is civil and earthworks for infrastructure are very important. Massive part of that construction process, and the amount of earth that gets moved around is important to measure, calculate, and then feed into that process.
I will just add as well that just from some I guess, anecdotal studies that have been happening internally. A lot, like Jared said, a lot of those principles do apply. So the build up, not down. A lot of bridge decks for, significant bridges are pretty similar from a carbon perspective, regardless of what options are done there. And it's really around the piers and subsoil options around what type of piles are adopted that can have the biggest difference, and particularly material sourcing. So we did try and put a non-building lens on when writing the tips to make it agnostic. There are definitely some more specific tips that could be developed. And again, we do welcome maybe a sub-working group to develop those.
I suspect that soil structure interaction discussion, but also bringing a carbon lens to that, and which probably is one of the top tips already, that's just communicating impacts and coordinating with the design team, making sure you're working really hard with your geotech, not being overly conservative, leading to overly sized concrete elements and heavy reinforcing. That's probably something to consider.
We've got a question here regarding treatment of timber and whether treating timber increases the carbon emissions associated, the upfront carbon, significantly. Would you like to take that one, Phoebe?
Yeah, sure. H1.2, nope. H3 and above, yes. It can add, I think it was like a 30% uplift in upfront carbon intensity of some timber elements to go with the higher treatment option. So definitely worthwhile considering in terms of whether that makes a difference if you're choosing between different materialities. Probably not so much, but it can be really impactful. Not so much for H1.2 though.
So perhaps the key recommendation there is to not over-specify timber treatment. There's a follow-up question to that one regarding the chemical impact of timber treatment and whether that's something that you would consider.
If we're talking about carbon, then it's considered. You would have seen that carbon is not the only impact that life cycle assessments cover. It covers a whole lot of different impacts around, eutrophication of local fresh water and saltwater sources, acidification, a whole lot of other environmental impacts. So those should all be captured if you are doing a full and formal life cycle assessment. From a carbon perspective, those numbers are available. But as with any sustainability objective or outcome, it is a holistic approach, and you need to decide what is going to be most prioritized amongst a whole range of different sustainability outcomes that you're trying to get.
Yeah, finding the right balance for your project. Great, I think we're coming to the end of our questions. I will just do a final check through to make sure that we've answered most of them, but you can reach out to us as a Sustainable Design Task Force with follow-up questions if you like. But otherwise, we might be able to finish a little bit early. So thank you, presenters, for your case studies. And hopefully everyone who logged on got some valuable information from the session and are all going straight away to download 21 top tips and read through them. I'll just pass back to Engineering New Zealand to wrap this up.
Thank you, Lisa. Thank you to everyone that joined us today, and a big thank you to our presenters as well. If you do have any further questions, please feel free to get in touch via that email Lisa just said, or through techgroups@engineeringnz.org, and we can pass those questions on as well. And just a reminder that this webinar was recorded today as well. Thank you, everyone, and have a good afternoon.